How much weight can the Tesla Cybertruck take on its trailer hitch before something breaks? Well, Zach from JerryRigEverything tested exactly this, and the hitch snapped off of the rear casting when the scale was reading 10,400 pounds of force, a number that's actually less than the Cybertruck's 11,000 pound tow rating. Now, seeing this hitch failure led me to 5 questions, which we will answer in this video. First, what do regulations say this hitch needs to be able to support, considering the vehicle's 11,000 pound tow rating? Second, are there any real-world scenarios where we could see the Cybertruck hitch hit 11,000 pounds of vertical load, say under heavy braking or perhaps hitting a pothole? Third, what are the industry standards for other OEMs? In the video, we saw Dodge Ram 2500 handle close to 11,000 pounds without failing. So for those who have been in the trucking business a long time, what are their requirements? Fourth, are there any fatigue life concerns, considering the Cybertruck's hitch is attached to an aluminum casting rather than a steel frame? And finally, should customers be concerned about towing at rated capacity with a Tesla Cybertruck? Alright, so let's start off with how much weight should a trailer hitch support? The Cybertruck has a tow rating of 11,000 pounds, and as such has a maximum tongue weight of 1,100 pounds. In other words, the amount of weight resting on the trailer hitch when the vehicle is stationary is 1,100 pounds, or the industry standard of 10%. Nothing unusual there. Okay, but what do regulations state the hitch needs to be capable of supporting? Well, there are 3 critical interactions that the Society of Automotive Engineers, SAE, point out. First, there's the coupling itself, which attaches to the trailer. Second, there's the internal mechanism of the coupling and how it attaches to the ball of the trailer hitch. And finally, we have the hitch itself, which attaches to the truck. Now, in the regulations, there are all kinds of different forces that will be applied to these components. For this video, we're just going to focus on vertical loads, since that's the kind of failure we saw in the video Zach posted. These requirements are all spelled out in SAE J2807 and SAE J684. Okay, so for number 1, the coupling. This needs to be able to handle half the towing capacity as a vertical load without breaking off or failing. So, in the case of the Cybertruck with an 11,000 pound tow rating, it needs to be able to handle 5,500 pounds. Number 2, the interaction between the coupling and the ball. This needs to be able to handle the gross trailer weight times 1.3, so 14,300 pounds. Now, you'll note that this is greater than where the Tesla failed. That said, this regulation is not about testing the vehicle itself, it's about testing this coupling. You really don't want this internal mechanism to fail in tension or compression, both of which have requirements for the same force of at least 14,300 pounds. Okay, so finally we get to the truck itself. And this is very clear because the regulation states the hitch shall be attached in such a manner that the loads indicated in Table 3 are transferred to the towing vehicle without incurring loss of attachment. In other words, it needs to be able to handle these loads without breaking the hitch or breaking off from the vehicle. So the maximum vertical load indicated in Table 3 is 0.47 R plus 480 pounds, with R being your trailer hitch's rating in terms of maximum trailer gross vehicle weight rating. So 0.47 times 11,000 pounds plus 480 gives you a load of 5,650 pounds that you need to apply to this trailer hitch, and it needs to be able to withstand it for at least 5 seconds. Alright, so the Cybertruck broke at about 10,400 pounds, but per SAE, it only needs to support 5,650 pounds before failure. So from a requirement standpoint, no problem. Whew, okay. Sigh of relief if you're a Cybertruck customer. However, just because you meet the minimum requirements doesn't necessarily rule out the possibility of problems in the real world. So my next question, is there a real-world scenario in which you could reach 10,400 pounds of vertical load on the trailer hitch? And to be clear, I'm not talking about abuse. That's very easy to do, whether that means towing way above the vehicle's weight rating, putting more than a 10% trailer tongue weight, jumping the vehicle while towing, or perhaps flying down the highway at 100 miles per hour and hitting a massive pothole. I guarantee you, in the right abusive circumstances, you can break this hitch off. We've already seen videos of it. What I'm curious of is there a way to exceed 10,400 pounds of vertical load on that trailer hitch following the guidelines outlined in the Cybertruck's owner's manual to the T? Can you do everything right and still fall into a situation where you'd exceed that vertical load? Okay, so Wes Morrill, Cybertruck lead engineer, tweeted, "Zach's test demonstrated about 10 times factor of safety on rated tongue weight. This should inspire confidence to use the vehicle up to its maximum rating." Now, Wes's statement is accurate, but I do think it's worth pointing out, as I am sure Wes is well aware, that 10% of the trailer weight is not the maximum force that you're going to see on the trailer hitch. Why? Well, 3 simple examples. First, you have load transfer. So as you're braking, you're going to have some of that trailer's weight shift to the trailer hitch. Second, road irregularities. You're constantly hitting road irregularities as you're driving, whether big or small, and that is changing the loading at the hitch. The biggest concern here would be hitting a pothole at speed, which could spike the G-forces at the hitch. And finally, while the world may be flat, roads are definitely not. If you're traveling downhill, you're going to shift more of the trailer's weight to the vehicle's hitch. Okay, so it's fair to say it has about a 10x factor of safety in a static situation where the vehicle isn't moving on flat ground, say sitting at a stoplight. But in dynamic situations, it is not fair to say that it's a 10x factor of safety. Alright, so is it possible that the hitch could ever see its full towing capacity on it? It's time for the whiteboard. So here we have our Cybertruck, and it is towing a Mad Max style fuel pod. And this is all designed to be very simple to understand and to prove a point. So we're pulling along this fuel pod, and you can look at where's its center of mass, and that happens to be about 3 feet back from the trailer hitch from the Cybertruck, and it happens to be about 3 feet vertically from that Cybertruck's trailer hitch. Now, if this whole system is to slam on the brakes for panic stop, and we're braking at 1G, well, then we can look at all of the forces involved and sum them about this point right here, simple statics engineering problem, and set all of those equal to 0, all of those moments. So this force right here is going to be mass times acceleration, right? Well, we know what our mass is, and we know what our acceleration is, 1G, we've got that panic stop, so that's going to give us our 11,000 pound force. Now, we multiply that by 3, and then we're going to set that equal to whatever force number 2 is, the force from the trailer hitch pushing up, also multiplied by 3. Of course, those are going to be equal, right? You do the math. Turns out force number 2 is going to be 11,000 pounds that Cybertruck hitch needs to push up in order to counteract that moment from this high center of gravity mass wanting to push that load as you brake onto that trailer hitch. In other words, the entire weight of the trailer is now resting on that trailer hitch. Now, of course, this problem was designed to prove a point. There are very good reasons why you'd never want to tow something like this with a simple passenger truck. But there wouldn't be anything illegal about it, and more importantly, it proves a point. If you have a high enough center of gravity, load transfer alone means you could get the full weight of the trailer on the hitch. Now, you'd probably crash if this happened. That's so much force and it'd be incredibly unstable. But this is just focusing on one variable so far, weight transfer. What about other factors, like a pothole? Well, a pothole could add another 3 Gs of force to the situation. We'll get to where that number comes from later, but consider if you're in a situation where you're braking and 25% of the trailer load is now resting on the hitch. Of course, not that difficult to think up. We've already shown that you could have much higher than 25%. Then while you're braking, you hit a bad pothole and get an additional 3 Gs of force. Well, boom, 25% trailer loading plus 3 times that 25%, and that gets you at 100% of the trailer's load on that trailer hitch. So there you go, a force big enough with only 2,750 pounds of actual weight on the hitch in order to hit the trailer weight as a load. And if you're going downhill, it only makes things worse, as you have more weight resting on the hitch. Alright, so with some combination of a high CG load, heavy braking, road irregularities, and going downhill, it seems very feasible that you could exceed that 10,400 pounds on the trailer hitch where the Cybertruck broke. To me, that seems concerning. Now, obviously it's a very rare scenario, but even still, it seems possible while following all of the rules. Now, this brings up optimization, right? Because so it's clear, I absolutely don't think the engineers at Tesla are dumb. In fact, quite the opposite. Engineering is always a matter of optimization, and you choose materials, thicknesses, and designs based on where you want the product to be. If you want a hitch that can hold 100,000 pounds, it's easy to design it to do that, right? But if it doesn't need to, what's the point? You're just wasting money and making something heavier needlessly. But if you go too far in the other direction, the product breaks and now customers are unhappy. So it's an intentional choice. What should the product be able to withstand? Now, I don't know the answer to this question, so I chatted with an engineer at Ram to paint a more clear picture. They've been making trucks for 100 years. So how do they target where a truck's strength should fall? Okay, some backstory. Independent of this video, Ram is launching the new Ram Charger, a plug-in pickup, which has a tow rating of 14,000 pounds. I had the opportunity to chat with their engineers, and I thought, hey, what a perfect opportunity to chat with a traditional automaker and see how they approach towing. And if you haven't seen it, I have a whole video deep diving into how manufacturers land on their tow rating number. It's a fascinating watch. And just so we're clear, this is not Ram's opinion on the Cybertruck. This is simply me taking advantage of a situation I had to chat with their engineers, and then, maybe I'm going to compare all that to Tesla. So the first thing I asked Ram about was the regulations, and if they had their own standards or simply go by what the regulations state when it comes to hitch loads. And they basically said the equivalent of, oh, the regulations are really easy to meet. If we only met the minimum requirements, customers would be unhappy. So I asked what they meant, and they brought up the example of SAE J684, which states, the hitch shall withstand the applied forces without incurring permanent deformation more than 5 degrees from the original position. And their point here was, okay, imagine a customer sees the maximum load outlined by SAE guidelines for the Ram Charger. In this case, it'd be just over 7,000 pounds. Now, there are dynamic situations in which this can happen, so the customer has done nothing wrong so far. So you're using the truck, abiding by all the rules, and suddenly your hitch bends down by 5 degrees. 5 degrees! So you go to Ram and you're like, what the heck? And then Ram just points at the regulations and says, that's allowed, that's fine. I think rightfully you'd be pretty upset. So understandably, Ram has their own internal metrics that the truck needs to handle. Now, they didn't share a ton of specifics. Of course, companies protect their internal info. But they did share some. That includes that instead of doing their testing with a 10% tongue weight, they do it at 15%, making it harder. And they have their own internal fatigue requirements. For Ram trucks, they target 120,000 miles of real-world towing. Now, internal targets are always going to be higher than warranties, right? So when they look at the engineering optimization problem, they're saying, okay, who's a very high use, at capacity towing customer, basically 95th percentile, and how do we make sure our product keeps them happy for the life of the truck? So Ram runs their own fatigue test where they connect a trailer to the truck and run it on their proving grounds on rough roads that impart loading into the truck and trailer. There's bumps and potholes and starts and stops, and the truck and trailer are fully instrumented with strain gauges and load cells, and they look at the load trace over time. And they said that in addition to the tongue weight, they can see G-forces spike as high as 1, 2, and even 3 Gs. They did say they wouldn't expect to see much higher than that unless you're traveling at really high speeds or hit a really bad pothole. So that's where that additional 3G force I mentioned comes from, real-world testing. Okay, now something else Zach brought up in his video was fatigue limits. So I asked Ram their thoughts on using steel versus aluminum in their frames and why they choose what they choose. Now, they were quick to point out that they use plenty of aluminum in their products, but for all Ram truck frames, they use steel, and they brought up 3 big reasons why they use steel versus aluminum. The first thing they mentioned was stiffness. Steel is about 3 times stiffer than aluminum, meaning it resists bending and deformation better under load. Of course, you don't want your vehicle bending under the loads of towing, But you can also design with material choices and thicknesses to avoid that. The second reason they mentioned was fatigue life. Okay, so we need to understand something called an SN curve because this highlights a very distinct and powerful difference between steel and aluminum. So here we're looking at, on the y-axis, we have stress, or S, and on the x-axis we have cycles, or N, the number of cycles. And so what this is showing you is if you apply a certain stress, let's say a high stress, for a certain number of cycles, well, that's where you can expect that steel to fail. Now, steel has something interesting about it in that it has an endurance limit. So after a bunch of stress cycles, eventually it reaches this endurance limit. And so long as your stresses applied to that steel are less than this endurance limit, it's never going to fail. So just as an example, say you're an engineer designing a product, and you know that the stresses that are going to be applied to that product, say a truck frame, are never going to exceed a certain stress. Well, you know then that that truck frame will last forever. But if your truck frame happens to be made of aluminum, aluminum does not have a fatigue limit. So the more cycles you have, the weaker it gets. Always, even if those cycles are at a very low stress. Eventually, that aluminum is going to fail. So you have to be very careful about how many cycles is this product going to see, and can I ensure that it will never reach a point where that product is going to fail after a certain number of cycles at a certain amount of stress. So again, putting this in context of our Hitch test, you can design a truck with a steel frame that meets the SAE requirements for an infinite amount of time, so long as the stresses remain below the fatigue limit. But you can't do this with an aluminum frame, so long-term, steel is the better option. In terms of the Cybertruck, it means the weight required to break the hitch off will decrease over time. Now, I asked Ram if there are any SAE requirements surrounding fatigue life for trailer hitches in the United States. And it seems there are cyclic tests for certain hitch types like goosenecks, but not for this kind of conventional trailer hitch. However, there are fatigue life requirements in Europe, and Ram does ensure that their trucks meet these requirements. It's worth noting the Cybertruck isn't sold in Europe. Alright, the third reason they mentioned preference of steel rather than aluminum for truck frames is that steel has a toughness about 5 to 10 times greater than aluminum. So toughness is looking at how much energy a material can absorb without fracturing. In towing applications, you have impact loads at the hitch ball, and so steel does a much better job of absorbing these impact loads than you would get from cast aluminum. Another way of describing this is that steel is strong and ductile, so it can handle high loads, and when the loads get too high, it deforms. Aluminum is also strong, but it's more brittle, so it breaks when the loads get really high. And that's exactly what we saw in Zach's comparison. The Ram probably experienced some deformation, but it didn't break, whereas the Cybertruck's rear aluminum casting did break. So the Cybertruck uses stainless steel on the outside, which is objectively very tough, but it uses aluminum on the inside. It's like the appearance doesn't really match what's going on inside. Which reminds me of something Elon said during the Cybertruck presentation.
You want a truck that's tough? You want a truck that's really tough, not fake tough?
I agree, and this leads me to a very powerful quote in the European requirements for mechanical couplings for towing. Regulation 55.4.2 states, all parts of the mechanical coupling device or component whose failure could result in separation of the vehicle and trailer shall be made of steel. Wow. Now, it does go on to say other materials may be used provided that equivalence has been demonstrated. Okay, so you'd still need to show that aluminum could demonstrate equivalence, but I think just a very another strong point where it's like, well, steel does make the most sense for this application. So this leads us to our final question. Should customers be concerned about towing at capacity with a Tesla Cybertruck? And to be honest, I don't know. Here's what we do know. Number one, the Cybertruck does meet the loading requirements outlined by SAE for towing at its rated capacity. That's good. Number two, it does seem there are real-world scenarios in which you could reach the tow rating on the trailer hitch, which is above the force we saw the tow hitch brake at. That's not good. And number 3, the Cybertruck uses aluminum rather than steel for the rear casting, which is what the trailer hitch attaches to. And we've explained numerous reasons why this is not the ideal material for the job. So another point doesn't seem great. If I could ask Tesla just one question, it would be, how many miles towing at rated capacity is the Cybertruck's rear aluminum casting designed to handle? I think, depending on the answer to that question, it could help alleviate a lot of customer concerns. And I think part of the reality of the situation is that time will tell, right? These trucks haven't been out very long. So how are we to know for certain at this point whether fatigue failures are something to be concerned about? But I also can see the argument that there are valid reasons to be concerned regardless, because steel seems like a much smarter choice for towing, especially if you're marketing a truck as really tough, not fake tough. So what do you think? Any engineers watching this that want to provide their opinions or any context? Happy to hear it. Also, a huge thank you to Zach from JerryRigEverything for sending me all of his footage to use in this video. If you haven't yet seen his video, it's a fun watch. You should absolutely check it out. I'll include a link. As always, if you have any questions or comments, feel free to leave them below. Thanks for watching.